Good evening, and hello, and welcome. And there are some bits of this talk which are going to go a lot better if you folks are on the internet, and there is no mobile reception in this room, so the Wi-Fi code will pop up from time to time throughout the talk. And yeah, welcome. I'm Dylan Beattie. This is me. I'm the guy in the hat, because otherwise I'm the white man with the beard at the software conference, and there's a lot of us. I am a Microsoft MVP with the Microsoft Developer Tech Program, which means I get little bits of free stuff from Microsoft, so thank you them for that. I run a .NET user group in London, and the thing that I sometimes get recognized for in the airport and that kind of thing is I invented a programming language based on Bon Jovi lyrics as a joke. It's called Rockstar. And the idea is that anyone can be a Rockstar programmer. So if you've got a code with rockstar.com, you can write programs that look like heavy metal songs, and then they will compile and they will run, and then you can be a Rockstar programmer and go and get all those cool Rockstar programmer jobs on LinkedIn. Not that there's any jobs on LinkedIn, but I'm sure they're coming back any day soon. Now, this talk has been, it's a talk, in one sense, it's a talk I've done a lot of times. In another sense, it's a talk that I've never done the same way twice, because it's been around for a while. And quite often when I do this, people will come up afterwards, or they'll leave comments, and they will tell me things that I didn't know, or they will pick up things that I said that they did not agree with, or that they thought were mistakes. And sometimes they're right, because you can do all the research in the world, but if you want to get schooled on something, the best way to get the experts out of the woodwork is to put it on YouTube with you telling them the wrong answer. But other times, so this is from a version that I did in Oslo in 2021, and some people in the comments had opinions, like Braden, who said, of course there's such a thing as plain text. Plain text is the plain text MIME type, or more generally text with special form. Yeah, so Braden wrote Braden wrote an essay in the YouTube comments about this talk. I don't really know what Braden was getting at with this, but a lot of it is interesting things that people have shared with me. But yeah, the question is, can you make an entire talk about plain text? And I think you can. The reason I think you can is plain text is one of those things we don't think about. And when it goes wrong, we're like, well, text can't go wrong, but it went wrong, but it can't go wrong, and I have no idea how to fix this now, because it's like the gravity stopped working on something. And most of the time, when we say plain text, we're talking about ASCII. And ASCII is one of those things, it's been around for longer than I've been around. We take it for granted. Computers just run ASCII most of the time. And we forget that ASCII was designed by engineers to solve problems. And the thing that we kind of gets lost in the translation, it was designed by American engineers in the 1960s to solve the problems that Americans had in the 1960s when they were using computers that looked like this and computers that looked like this. Because they didn't have screens yet. They had mechanical teleprinters. And so if you look at the ASCII character set, the first block, this thing here, this is control characters that make mechanical teleprinters do stuff. And the first one there, the null character, that's all the zeros. That's your C end of string terminator. It always has been. And then you've got your start of heading. And if you wanted to send start of heading to your teleprinter, you'd hold down Control and you'd press A, and it would start the heading. And if you wanted to send start of text, you'd press Control B. And if your teleprinter is going brr, 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 and you're like, no, stop, there's been a horrible mistake, you press Control C. And that one survived, because I did that this morning. How many of you have done Control-C today? Yeah, there's a fair few. And Control-D is how you tell Python you're finished talking to it, end of transmission. And there's a bunch of characters in here about backspaces and tabs. And then we get into line feeds and form feeds and carriage returns. And this is where things get a little bit interesting, because a mechanical teleprinter had a thing called a carriage. And the carriage starts at the left side of the page, if you're writing American English. And when you print a line of text, it goes running off over there, and it prints as it goes. And then you needed to return the carriage to the left margin, and then you needed to feed one line through your printer. Now, teleprinters were kind of dumb. They couldn't do fonts. They couldn't do very much formatting. They couldn't do large, small text. One of the very few things that they could do is you could print a line, and then you could return the carriage, and then you could print the same line again. And because it didn't quite line up, you'd get this faux bold effect. So a carriage return on its own was useful. People used that to do stuff. A line feed on its own, not useful, because that just means you've advanced a line, but your carriage is still over here. And so what we've ended up with years and years later is this weird situation where if you have a Linux machine or a modern Mac OS machine, it says, yeah, line feed is just a /n, it's just a new line. And the reason is that modern Unixes and macOS and Linux, they evolved out of, well, Unix, which evolved out of a system called Multics. And Multics was the first operating system in history that had device drivers. You could put a little bit of code between your text files and your teleprinter that was smart enough to go, look, if you give me a new line, put in a carriage return as well, because that's obviously what you mean with this. Windows, Windows is not smart enough to do this. Because, well, Windows is smart enough to do this, but it can't, because Windows 11 evolved out of Windows 10, which evolved out of Windows 8, 7, all the way back through Windows 2000 and Windows XP, and Windows 98, Windows 95, Windows 3.1, which ran on MS-DOS, which was built on top of CP/M, and CP/M was designed to run on the cheapest computers available, so they could sell lots of copies, and they didn't have device drivers. So CP/M, you had to send the carriage return, otherwise you'd fall off the other end of the page. And so this is why, you know, however many 60 years later, we are still, if I send you a text file, sometimes you can't open it right because of a disagreement about device drivers going back about 50 years. Now, the next chunk of ASCII is full of things I actually think are really clever. So one of the blocks that's in here, we got a bunch of punctuation. And one of the decisions that the engineers of ASCII had to make is, what do we include? Because they did not have enough space for all of the characters that were used in publishing in American English in the 1960s. One bunch of characters that didn't make the cut were, you've all heard about the M dash, right? Because today the M dash is, some people are like, well, it means you used AI. And the reason is that AI has been trained on professionally typeset material, which has used M dashes for centuries. But then they fell out of favor because we didn't have space for them in ASCII. And then they kind of came back into favor with the advent of things like Kindles and Unicode, which we're going to talk about. All that's in ASCII is hyphen. That's it. You got one little line, and that's your minus sign and your hyphen and your dash and anything else that looks like that, and your line drawing menus and things. So they had a lot of stuff didn't make the cut. For a long, long while, we just did not have these symbols. The decimal numbers. One of the things that computers have to do a lot is they have to turn information that a human can read into information that a microprocessor can read and back again. So if you want to turn an ASCII digit into its binary representation, you just take that half. And that's fast. That's really fast. Even on a 4-bit CPU from 1965, turning the character 0 into the value 0 is blistering quick. Then we get into the letters of the alphabet, the Latin alphabet, which is the one that American and British and Commonwealth English all use. And if you've ever, the first time I looked at an ASCII table, I was like, why did they choose 65 and 97? Why are those the numbers that got assigned to uppercase A and lowercase a? And the reason is actually really clever. If you have the binary representation of ABC and you want to do a case-insensitive comparison or a case-insensitive sort, you switch off that bit. And now they're the same because they are 1 bit apart in the binary representation. So we wrap up the ASCII, we've got a bunch more punctuation characters kind of filling in the gaps, and then right at the bottom, ASCII 127 looks like this. This is the ASCII delete character. And ASCII delete is all the ones, because in the days before flash memory and hard drives and tape, data got stored on paper tape. And you can't fill the holes in. If you need to erase some top secret military information that is on a paper tape, you have a choice. You can burn it, and they don't like you putting things on fire in computer rooms, or you have to go back and punch out all the rest of the holes so that no one can read what used to be on it. And that's why ASCII delete is all the ones, because if you print delete onto a tape, it wipes it out, you can't read it anymore. 1965, United States of America, hey everybody, swell job, 127 characters, all you're ever going to need. And the rest of the world goes, sorry, what? We can't work with this. Well, no, it depends. It depends where you were. There were a lot of places around the world where ASCII's fine. It solved all the problems that they had, and yeah, that's it. Computers are good now. There's a lot of other places where anybody who grew up speaking, reading, writing Hebrew, Japanese, Cyrillic, any of those languages or alphabets, you're like, no, ASCII is not going to work for us. But there were a lot of places where it was nearly good enough. Now, I spent my childhood in Zimbabwe speaking English, and Zimbabwe uses dollars and cents. So ASCII was good enough for English speakers in Zimbabwe. Then when I was 10 years old, I moved to the UK, and I had a 286 PC with a megabyte of RAM, I had an Epson dot matrix printer, and I was doing my homework on the computer because I was a nerd, and I wanted to print this. And I sent it to the printer, and what came out was that. And the reason is that when the Americans made the call about what's in and what's out, the pound did not make the cut because it was not frequent enough in the American English corpus that they analyzed. Which means that my computer and my printer did not agree. They could both do this character, but they didn't agree on how to do it. Because what happened is a whole bunch of different people, companies, organizations around the world, they looked at ASCII and they went, well, hang on, we got 8 bits in a byte. We've got 256 potential characters. ASCII only uses 7 of them. It's a 7-bit encoding. Is anybody using this bit? And of course, nobody was. No one standardized that. And so everybody standardized it. And we got lots of different standards. And if you've come across the term code page, a code page basically says this is what the top half of 8-bit ASCII means, right here, right now, on this computer using this document in this application. And the reason I couldn't print my homework is because I had a meter of printer cable and the code pages, the computer had one, the printer had a different one, and I didn't know how to change it. Now, there's a very famous code page. This is code page 437. It was the default code page on the original IBM PC Junior in the 1980s. This took basic ASCII, and it added the characters that were basically the characters that were used in countries that had IBM customers, countries that spoke English and had a lot of money. So Scandinavia, Western Europe, Northern Europe. It had all these little box drawing characters so you could do menus and build graphical user interfaces. And it had half of the Greek alphabet. You couldn't use code page 437 to send email in Greek because it didn't have enough letters, but you could use it to do high school physics because that was something that engineers wanted to be able to do. And so it's got the Greek characters that were used in mathematics and physics, but not the ones that are used by Greeks to speak Greek. And then somebody went, hey, well, the IBM PC doesn't have a teleprinter. What if we could use that top block to do fun things like playing cards and musical symbols and smiley faces? Now, if you've ever seen an original PC Junior crash really hard, what you get is a screen full of smiley faces and playing card symbols, because what it's doing is it's taking all of the low-valued machine code instructions and it's trying to print them using the default encoding to show you what went wrong, and you just get a screen full of this stuff. Now, there is an international standard code page for doing Cyrillic, which is the alphabet used Russian, Ukrainian, Belarusian, Bulgarian. The problem with the international convention is it's based on the Cyrillic alphabetical order, which seems like a good idea, but a lot of systems assume that text only used 7 bits. They assume that the 8th bit, you could do anything you like with it. There's an old word processor called WordStar. WordStar used the 8th bit as a kind of, have we spell checked this word, yes or no, so that when you ran a spell check, it didn't have to check things twice. When you edit a word, it would clear it, and when you spell check it, it sets it. To this day, if you send someone an email, it is 7-bit going across the wire and gets rehydrated at the other end. There's a thing called UTF-7. It's the ugliest encoding ever. It exists so that we can put Unicode in emails. But if you took a word like, anyone here read Russian? Anyone know what that says? Yeah, привет, means hi, hello. And you took that and you set that in your international standard, and then you sent it through WordStar and you lost your top bit. The numbers that come out look like this, and that's gibberish and it doesn't make any sense to anybody. So a bunch of smart people who actually wanted to be able to do computers in Russian invented KOI8, the Kod Ednema Informacja v 8-bit. And this is a brilliant encoding because it didn't use alphabetical order. It was based on what letters kind of sound the same. So if you took Privyet and you encode it and you lose your top bit and you turn it back into numbers and then you rehydrate it using regular ASCII, what comes out is something that sort of sounds a bit like the Russian that got garbled, Privyet. And they flipped the uppercase and lowercase, so you could instantly see that it had gone wrong, but you could just about read it and make sense of it, which I think is a genius encoding. Now, I did a version of this talk a few years ago. Someone comes up to me afterwards, they said, do you know the story about the Harry Potter book? I'm like, no, tell me about the Harry Potter book. And they told me the story and sent me a link to a Reddit thread. 2002, one of the Harry Potter books had just come out, and there's like a fan forum somewhere, and there's a lady in France, in Paris, and there is a lady in Moscow, and they are like internet pen pals talking about Harry Potter. And I filled in some details here with a little bit of poetic license. So we don't know if her name was really Claudette, but Svetlana Pletneva emails Claudette and says, hey, Claudette, that'd be amazing. Yeah, we can't get the new Harry Potter book here in Russia yet. Here's my address. It's in a Russian alphabet, so please copy it carefully. And there is a street address of an apartment building in Moscow. Thank you, Sveta. And then click send. And Claudette receives this on her French language Microsoft Windows 2000 with Outlook and goes, oh, Well, I guess that's how they write addresses in Russian, because, yeah, you know. Now, nothing has got lost. This is the same data, the same series of numbers being interpreted using a different encoding. The email got sent in KOA8, but then it got received in ISO 88591, which is the one that was used in French. So Claudette very diligently copies the address onto an envelope and posts it, and somebody inside the Russian postal system goes, oh yeah, I know this one, and corrects it, and the book gets delivered. Now, I want you all, take your phone out your pocket, and I want you to open up Spotify or Tidal, Apple Music, whatever it is that you use to listen to music. And I want you to search for that word.
Is that your band?
It's not my band. But it's something to do with a band. Anyone found anything? Billy Joel. Billy Joel and his band, in 1987, they became one of the first Western artists to perform in what was then the Soviet Union. And they did a bunch of concerts in Leningrad, which is now St. Petersburg, and they recorded them. And they were released in the Soviet Union, and the album was called Concert. And it was spelled in Russian on the cover, K-O-N-C-R-T, Concert. And this doesn't matter because, you know, it's fine. It's there. You can read it. That's what it says. And then at some point, somebody at BMG Music Publishing or whatever the record label was is like, oh, we need to put this in the spreadsheet so we can track all of our record sales. And so they got their American keyboard and they're K-O-H-U-E-P-T. Yeah, whatever. It doesn't matter. It's just internal. It's just a spreadsheet, right? Then streaming gets invented. And somebody rings BMG Music Publishing and says, you've got a big spreadsheet of all your records that we can put in our iTunes and in our Spotify so we can sell them all. And the spreadsheet becomes the database, and the database becomes the streaming. And Concert by Billy Joel becomes the album Kohuept, which is just what it's officially known as everywhere now because of an encoding problem. Now, the folks out there who can read a bit of Russian, what does that say? It doesn't matter whether you can read. If you can't read Russian, that doesn't say anything. If you can read Russian, it also doesn't say anything. It's complete gibberish. But if you type those characters on a Cyrillic keyboard layout, this is where you put your fingers. And if you make that same pattern on an international or English keyboard layout, it says Taylor Swift. And Google knows this. Because if you go on Google and you forget to switch your keyboard from Russian back to English before you do your Google, you can type in that, and Google goes, oh yeah, I know exactly what's going on here, because some Google search engineer obviously was switching between Russian and English and went, you know what would make the internet better? I'm just going to fix this. That, by the way, is my new definition of being really famous as a recording artist, is if you can type your name in Google in accidental Russian keyboard, and it knows who you are. Now, there are all kinds of fun stories to do with different code pages and encodings and transliteration problems and things, but this got unmanageable. If you go on Wikipedia and you look up code pages, this is the list of code pages that Wikipedia has links to. And it's not even just like there's different ones for Bulgarian and Hebrew, say. If you want to send an email in Bulgarian, you need to know, well, are you on Mac or are you on a Windows? Are you on an IBM mainframe? If you want to print it, are you going to use IBM Bulgarian or PostScript Bulgarian? What kind of printer are you using? This was basically unsustainable. And so as the World Wide Web took off and people started sending email and wanting to be able to communicate across borders, the Unicode Consortium was set up. And their mission statement was to provide a single consistent way to represent each letter and symbol needed for all human languages across all computers and devices. And this is brilliant, and the amazing thing is they did it, and it worked. And to me, there are three things that they had to get right here. All computers and devices. If you want everybody in the world to use your thing, you've got to build something really good, and you've got to make it completely free. Free as in speech, free as in beer, no patents, no licensing, first-class implementations on every platform. They did the work. They did that part. All human languages. It's not just the languages we use today. There are people out there right now doing archaeological research. They are writing notes in ancient Sumerian and Egyptian hieroglyphics and they want to be able to send email and publish papers and put stuff on the web. So all of those languages are in Unicode, which leaves us with each letter and symbol. And that's where things start to get spicy. Anyone recognize this flag? Yeah. Hungary. I was in Hungary last year, and I was talking to some people about text encoding, because that's what I do for fun. And they said, have you seen Hungarian Scrabble? And I said, no. So I got in an Uber, and I went to a Hungarian toy store, and I bought myself a copy of Hungarian Scrabble. Because if you have grown up playing English Scrabble, as I have, if you enjoy word games and things, you'll know that in Scrabble, if you can play a 7-letter word, you get a nice big 50-point bonus. And the word Nemczak is a Hungarian word. Nemczak szertiszik, hanem whiskitish means he doesn't just drink beer, he also drinks whiskey. But in Hungarian Scrabble, that's not a 7-letter word. Because in Hungarian Scrabble, ch is a single tile with 2 letters on it. Yeah, I had feelings when I first took all the tiles out of the Hungarian. So I went down the road, like, who gets to decide what is a letter of the alphabet and what isn't? Because the people who made Hungarian Scrabble, they went, oh yeah, these are letters. This is just one letter as far as Scrabble is concerned. The Hungarian government, who, if anyone's going to make the call, we should probably let it be them, right? Because we don't want to upset anybody. They say the Hungarian alphabet has got 44 letters in it. Used to have 43, then in the 1980s they added another one. So this is the Hungarian alphabet. These ones, these are the same letters that we get in 7-bit ASCII. So those ones are fine. We can just use all the keys and the codes and the Scrabble tiles that we had the whole way along. These ones, these are in Unicode as a single code point. So Unicode says, yes, that's a letter, here's the code for it, that's one single letter, put it in your font, put it on your phone, all that stuff is going to work. Now, there is a Unicode code point for the letter D. D exists because of a weird edge case. The Macedonian language is written in both Latin and Cyrillic, and you need to be able to translate from one to, or transliterate from one to the other and back again without losing anything. So because of this requirement, there is a Unicode code point for the letter Z, which is a digraph, 2 letters in 1 point, which has 3 different versions. Because there's the capital, a capital and then a small, small. So it's got 3 different capitalizations. This letter appears in the Hungarian alphabet, but they don't use this Unicode symbol for it, because that's not how they do things. And the main reason is that they don't have that key on their keyboards, because a Hungarian MacBook keyboard looks like this. So we have the digraphs, which are the ones that you get just by typing one key after another. There is one trigraph. The letter J, as in welcome to the jungle, which is the same word in Hungarian, that is 3 letters, but it's also 1 letter according to the government. And then these ones here, those are not actually Hungarian letters. They have them because they're used in international loanwords and names and businesses, but there are no native Hungarian words that include any of those letters. So when it comes to each letter and symbol, we use Hungarian as just one example. We have got 35 of them are keys on your Hungarian keyboard. We've got 41 of them appear as tiles in your Scrabble set. We've got 36 of them in the Unicode code point, except Z isn't there. They don't use that one. So boing, that one's going to go off over there, and we're just going to use DZ to get that. If you've grown up reading and writing and speaking English, you haven't had to even think about any of this, because this is what we've got. We got 26 letters, 26 Scrabble tiles, 26 alphabet keys on your computer keyboard. What's the big deal? And this is why so often when companies, they have some software that works brilliantly in the country where they were founded, and then they go to expand internationally, you get developers going, I don't get it. What do you, how does any of this, how does the text break? And you're like, the text breaks because it only works with your text, and your text is not the same text as the rest of the world. Let's meet some friends of mine. Francois Borde is an archaeologist from France, and Motley Crue is a rock band from Los Angeles. And Francois, the archaeologist, went to the Motley Crue concert. What language is that written in? It's not a trick question, it's English. Like, you know, if Francois went to see Motley Crue, you might write about that when you wrote about it. And then, but we got these letters here, which are not part of the Latin-English alphabet. We've got the C with a cedia, which is an import from French because Francois is French. We've got the AE here, which is a typographer's ligature, which is a stylistic thing that some publications still use. And then the O and the U there, that is the heavy metal umlaut, which is a thing that American rock bands do because they think it makes them look cool. And then they go on tour in Germany, and the audience shout, Möchtliche Kur, because that's kind of how you'd pronounce that if you know how to speak German. And Motley Crue don't know how to speak German. And so they're like, hey, man, why don't they know our name? And it's like, because you screwed it up, trying to look cool. All right. I'm going to put a word up on the slide. I'm going to count down 3, 2, 1, and then on 0, I want all of you to shout out that word, all right? 3, 2, 1. Did I hear lods from? Yeah. So we got a couple of lodses. Did I hear wads from anybody? Any wodges? Yeah. How many for wodge? Yeah.
Terrible crowd, man. Like, loads of Polish people.
Because if you've grown up reading and writing American English or Canadian English or English English or Australian English, to you, this is English with salad. And just like eating a cheeseburger, you ignore the salad and get on with the important bit, and so to you, this says lods, because that's what you got. But it's not. This is not English. This is Polish. This is the city of Łódź in Poland. But if you are in Poland and you are on Google Maps and you are using an English phone, you don't have the letters to write Łódź properly. All you can type is Lodz. So you're going to put Lodz in, and Google Maps needs to be smart enough to know that you meant Łódź, because there isn't a place called Lodz, and that's probably where you're looking for. And this crops up all over the place. When you travel a lot and you're relying on Google Maps and local apps to buy train tickets and find your way to the airport and all that kind of stuff, it is amazing the extent to which people make assumptions about how somebody else's names and towns and cities should be rendered into your alphabet. Let's meet Magnus. Magnus Martin, no, not Magnus Martinsson, Magnus Mortensson, because that letter there, or, that is the 29th letter of the Swedish alphabet. Because Swedish has A to Z, same as English, and then it's got A, O, E, and Ö as 3 extra letters. And Mortensson, now a couple of years ago, Magnus is on his way to Microsoft for the MVP Summit, and Magnus has a Swedish passport. And if you look at any passport, there are these 2 rows at the bottom. That is machine-readable 7-bit ASCII. It has to be because airlines still run on IBM mainframes from the 1960s. The rules of Swedish orthography say that if you have to turn the letter O into ASCII, it comes out as AA. So O becomes 2 A's. The people who print Magnus airline ticket, they don't know about that. They just take the salad off because it can't be important. So Magnus is trying to get into the United States with an airline ticket that doesn't match the name that's printed on his passport. And you know how kind and understanding the Americans are about that kind of thing. Now, you know, it's funny because it is funny, but it's also a big deal. You think about the number of people every day who are trying to cross an international border or get a job or apply for an apartment or open a bank account, and they can't do it because the name that they were born, the name they grew up with, does not fit in the mainframe, and different people have different opinions about what has to be done to it. There's a guy in the Netherlands at the moment who is suing his bank because they can't get his name right because their mainframe computers cannot put the correct diacritics on it. And he's saying under the GDPR, they have to call him by his chosen name. And they're saying, but we can't because IBM can't. And he's like, will you fix it? And they're like, look, how much money do we just have to give you to go away? Because no matter how much money you want, it's less than it'll cost to upgrade our mainframe banking software and all of the interbank software and everything else to support character encodings. Now, despite all these complexities, we can at least agree that letters, there's like an uppercase and a lowercase, right? And you take a letter and you uppercase it and then you lowercase it, and that's reversible and it's consistent and it's, we can do this. This is always gonna work consistently, right? Turkey has entered the chat. The Turkish alphabet has a dotted I and a dotless I. And if you book a plane ticket to Istanbul, Istanbul has a capital I with a dot on the top because it is spelt with that letter. Now, you've got to imagine here that you are trying to solve the problem of how to put Turkish in the computer. So you've got a little I with a dot on it. That exists. The Americans have that. It's on your computer keyboard that you just bought from IBM or Dylan. And you've got a capital I which doesn't have a dot on it, and that's fine. That's there. But in Turkish, that is not the capital equivalent of that one. If in Turkish you capitalize the word, say, internationalization, you get that. And if you lowercase that, you get that. And those letters there do not exist in Latin. They only exist in the Turkish alphabet. So you've got a choice. Either you end up with 2 keys on your keyboard which have the same shape on them and you need to remember which one to push, or you have letters that if you are running a Turkish locale or a Turkish operating system, when you uppercase them, they're going to come out differently than they do everywhere else in the world. Wikipedia says this has caused some issues in computing. If any of you has ever done a string comparison by uppercasing both words to see if they're the same, Turkish is going to bite you in the ass because it will stop working when you do that. Now, let's take a look at our friend Francois again. So Unicode, one of the things they did is they said, we're not going to tell anyone how to do their jobs. We want to give you the set of tools that you can use to build systems that work for your customers and your markets. And so if you need to put the C with a Sadia, they say, all right, well, we'll give you a code point to do that, or we'll give you what's called a combining character. Decorations that you can add to anything else in Unicode. So you take your regular ASCII flavored C and you add this little combining diacritic onto it, and you get this character out the other side. Now, you can stack these things, because you can say, we'll take a Z and we'll add one of those and one of those and one of those and one of those, and just keep stacking things on. And this is where Zalgo text comes from, which is a really good way of breaking font rendering systems by just pasting that in and seeing, is it going to render, is it going to crash, is it going to brick your old Samsung phone? But it also means we end up with different ways to say the same thing. We take our friends in Motley Crue, we can write it as that, or we can write it as that. And so now we've got two different strings that look the same, and they mean the same thing, but they're different lengths, and they have different code points. And how do we do things like search and filtering and comparison? How do we tell if they're the same? And again, Unicode says, well, we're not going to give you the answer, we're going to give you the tools. It defines 4 normalization forms. So canonical decomposition, it says break this apart, decompose it into the widest possible number of code points. And canonical composition is crunch it down again. If you've got a combining character, turn it into the single code point. And then they went, okay, compatible, crap, we just used C to mean, okay, we'll spell compatible with a K. So K in Unicode is compatibility, and so we've got compatible, decomposition, and composition. So if we take a bunch of, this is .NET code, but the point is what we're doing is we're normalizing strings and comparing them. If we take our friends Motley Crue and we build that string in 2 different ways, one of them using this Unicode combining diaresis, what we get out of this is we get 2 strings, which they're the same length. They're not the same string. If we just say S1 equals S2, it's false. But they are considered equal under all 4 forms of Unicode normalization. The reason we have the different forms is that, for example, Unicode has got fancy text in it. There is bubble text, there is outline bubble text, there is fancy text for doing mathematical formulae and physics calculations and different things where you don't want to use a different font, it's just a typesetting consideration. But it's the same words, it's the same letters, it's the same alphabet, they're just different glyphs. And this is why we have the compatible composition, because under this comparison, same length, they are not equal, and they are not equal unless you include the compatibility normalization. So if you've got something, like a website where people can have a username and people are putting funny little bubble characters and stuff in their username, and then you need to search the database, you got to know about compatibility, composition, and decomposition, because you need to be able to search for Dylan written in fancy little bubble letters, or Dylan written in mock Gothic script, because I might put that in there, and if you don't filter on it, we'll never be able to find it again. Now, I mentioned the story of printing my homework on the 286 PC. That was kind of part 1 of my life's journey with text encoding. Part 2 came one day about 10 years ago. I went into the office and one of my team came over and says, dude, I think we've been hacked. And this happens a lot when you work in tech, because everyone always thinks they've been hacked all the time because they've accidentally gone right-click inspect and they think they broke the internet. But once in a while, the person saying, I think we've been hacked, is a security engineer who's quite good at their job. And so you're like, all right, why do you think we've been hacked? There's Chinese in the Windows event logs, comes the answer. And sure enough, there is Chinese in the Windows event logs. Now, that's not supposed to be there, because we're a British company in London with mainly English and European customers. None of us read, write, speak, or understand Chinese. We do no business in Chinese. And there should not be Chinese in the Windows event logs. So Incident Management 101, your job is go check the firewalls. Have there been intrusion? Look for Chinese IP addresses, suspicious traffic. Your job is to look through the database. Is it an injection attack? Is there Chinese being crammed into any of our text fields? Your job is go tell the business, maybe a security breach, update in 15 minutes. If anyone sees anything weird, especially if it's in Chinese, tell us about it straight away and get a screenshot if you can. Effective management is about delegating all the important stuff so that you can shitpost on Twitter. or Blue Sky now because we don't do Twitter anymore. And sometimes that's the winning strategy, because when I posted this, I got back, oops, that looks like a Unicode mapping error, and then the fake Unicode account said, yeah, the low bits are all null, so this is probably UTF-16LE being mistaken for UTF-16BE or vice versa. And I'm looking at this and I'm thinking, it sounds like those might be important. I should probably learn what they are quite quickly. So I spent about 3 hours learning Unicode as fast as humanly possible, and what I learned internally, Microsoft Windows, Java, .NET, JavaScript, quite a lot of modern systems, they store most characters as 2 bytes because this gives them a lot of space for extra alphabets and all those kinds of things. And so a SQL keyword like delete, this is stored in memory and on disk as 0044, 0065. So we got null and then a 44 and null 65. These are ASCII character codes, but and they're in hexadecimal, which is why this 65 here is the E. But if you flip them the wrong way round, that teleports you straight into the Unicode block that is used in Chinese. Now, a version of this talk on YouTube, someone left a comment on it saying, yep, in case anyone's interested, this is what the Chinese characters mean. This one is dismembering the body of livestock. This one means climbing. This one is textiles and fabrics. That one there, gems and pearls and jade put into the mouth of a corpse. Now, when I saw this comment, I laughed my ass off because it reminded me the day that it happened, one of the team came over and went, I think it might be a ransom note. And I'm like, what do you think? And I said, I think they want us to kill a chicken and put money in its mouth. And I'm like, I don't think that's what this is. But yeah, this is what the characters mean. So the question is, this is a Microsoft SQL Server talking to Microsoft Dynamics CRM. Why is it suddenly switching from big endian to little endian and back again? What's going on here? This took about 40 hours to figure out the problem, because what was happening is we would try something and the problem would go away and everything would be fine. It would come back up for about 3 or 4 minutes and then it would go down again. And then it would come back again, and then it would go down again. And this was just round and round. What we eventually worked out by basically DDoSing our own database server to see what made it break is we'd migrated everything into a new data center, and they were using this very high-tech virtual network which had a virtual switch in it that was faulty. And every 3 minutes, it was just dropping 1 byte silently, which meant everything else was just shifting sideways by 8 bits with no parity checking or anything. And so the thing on the other end was like, oh, cool, yeah, Chinese, I can read this. And so everything would screw up for 3 minutes, and then it would randomly drop another one, and everything would shunter, and it would line up again, and then it would break again, and then it would line up again. Now, this makes sense internally. When you are talking to your own memory on your operating system, being able to have a pretty good idea, if you've got 500 characters and you know they're 2 bytes each, you know that's going to be 1,000 bytes of memory that you allocate for that. For local storage, this is good. It's fast, it's efficient, it makes a lot of things easy. But once you get out onto the network, and particularly onto the web, everything kind of gets reversed because bandwidth becomes more important than optimizing for storage. If we take a web page, so now we're in Ukrainian Cyrillic, and this is Hello World. Now, there are the bits of this page here. This is that page written in UTF-16, which is Windows and Java's internal encoding. These bits need 16 bits because they are Ukrainian. Privyet means hi. The rest of it is ASCII, because HTML is made of ASCII, CSS is made of ASCII, JavaScript is made of ASCII unless you are twisted, in which case, please, I don't want to know about it. But what it means is that if we send web pages as UTF-16, we are sending null 3C, null this, null that, null that, null that, which is hugely inefficient. 44% of this data stream is us saying null, 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 and you can't compress it out because it's not that consistent. We don't have long recurring streams of things. And so the Unicode Consortium came out with what I think is probably the most brilliant hack in the history of information technology. It's a thing called UTF-8. And UTF-8 says, look, you got a bunch of bytes in a stream. If you have a byte that starts with a 0, that's ASCII. That is American 7-bit IBM-flavored ASCII from the 1960s, same as it's always been. All of those old documents floating around the web and Usenet and your C drive and your dad's old hard disks and everything, those are all still valid because we haven't changed that. If you have a byte that starts with a 1, it is part of a multi-byte sequence. Now, if it starts 1-0, it means you're in the middle of a multi-byte sequence, so you're going to need to backtrack. And backtrack until you get to 1-1, Then if it's a 110, this is the start of a 2-byte sequence. If it's 1110, it's the start of a 3-byte sequence. If it's 11110, it is the start of a 4-byte sequence. We could go higher. There is no point. 1, we don't have any letters for that. We don't have any fonts. We don't have any symbols. 2, we can't round trip it into anything else. 4 bytes, you can translate into UTF-32 and back again. So there is actually support for this. And there are scenarios where we need it, because we are still inventing new alphabets and new languages. Now, one, it's nice to know that when we make contact with the friendly aliens from Alpha Centauri, we've got enough space to put all their email into Unicode. But also, we are still inventing new alphabets of our own. Emoji. Invented in Japan around the turn of the millennium. There was a project, a guy called Shigetaka Kurita was an artist. He was hired by Japan's biggest mobile phone company to create little friendly symbols so they could do weather forecasts and train times and stuff on Japanese mobile phones. Everyone loved this. Within about 2 years, you could not buy a phone in Japan. Like, if you built a phone with that emoji, no one would buy it. So this became a standard. Meant when Apple went into Japan in 2008 with iPhone, they had to support emoji. And initially, this meant you had to put your phone in Japanese so you could get them. But then people started sending these around the world and texting, hey, dude, put your phone in Japanese and see what you can do with it. Which meant a lot of people started asking questions. Like, okay, cool, well, there's sushi, but there's no tacos in here. So how do I emoji text somebody to say I want to go for tacos? There's an airline pilot, there's a firefighter, there's a police officer. They're all men. Why are they all men? Where are the female police officers and things? And so Apple and Android, Apple and Google, they got together and they basically said, look, this emoji thing is a big deal. Nobody owns it. Our handset does one thing, their handset does something, Samsung had their own system. If we can standardize what exists out there, can we give the whole thing to Unicode and it becomes your problem now? And Unicode went, yeah, all right, but you get it standardized and then we'll take it over and we'll manage it. Now, one of the big steps that Unicode made with emoji in 2015 is they added the ability to put skin tone modifiers on things like hands and face emoji. And the way they did it is the same way we did Francois and Motley Crue. They used a combining character. So the thumbs up emoji plus the medium dark skin tone, that's a combining character. If your handset has the right artwork, then that will render as this. If it doesn't, you'll get a thumbs up and then a little block, which is known as tofu, because it's like a little white square. And you'll be like, okay, 1, I don't know what that says, and 2, it's probably time to get a new phone, or at least install that update that I've been ignoring for the last 3 months. Now, they have used this technique for all kinds of cool things. There is an emoji for a female astronaut. This is the woman symbol, followed by a thing called a zwidge, a zero width joiner, followed by a rocket ship. If your handset's got the artwork, you get female astronaut. If it doesn't, you get a lady standing next to a rocket ship and you have to figure it out. And you can use skin tone modifiers, so you can have a woman with dark skin standing next to a rocket ship, and if you've got an up-to-date handset, that's the emoji that comes out. Now, flags are where emoji gets really interesting. The flag of Canada, where I was a couple of weeks ago, is the regional symbol, indicator symbol letter C, A, because Canada is a country recognized by ISO, the International Standards Organization. It has what's called an ISO 3166 code. This is kind of like, there's a little bit of disagreement about whether some places are countries or not, but generally most people are like, well, if you've got an ISO 3166 code, then yeah, fine, you're a country. England, not a country, unless football is involved. For politics purposes, the United Kingdom is the country, England is not. But of course, we need the England flag because it's going to be the World Cup soon, and we need to be able to do emoji support for England or Scotland or Wales. And so the hack for this is that it is a black flag followed by GBENG from a block called the tag Latin small letters. The tag letters are kind of funny. They put them in an early version of Unicode going, these might be useful one day. 5 years later, they took them out because no one was using them for anything. And then someone went, no, we're using those. That's how we do the England flag on iPhones. And they went, oh, better put them back in and pretend that we never took them out. And so those are still in there. And this is the convention for doing flags, which are geographical flags that don't belong to a country. So England, Scotland, Wales, and the flag of Texas is in there as well. And I'm sure in time we're going to get a couple more.
Why are those numbers the same?
Huh?
They're all E65.
Because it's a copy and paste error.
Oh, right,
yeah.
okay.
You're not supposed to look that closely. And the pride flag is a white flag followed by a zero with joiner followed by a rainbow, which I think is rather nice. Now, you recognize this flag. This is the flag of, this is the flag of the Republic of China. But most people know the Republic of China as Taiwan, because the country we call China is the People's Republic of China, which is a different Republic of China. And in the People's Republic of China, this flag is illegal because it is a symbol of Taiwanese independence, and they don't like that. Now, if you have an iPhone and you go onto your keyboard and you type Taiwan, you get a little flag pop up, and then you go into your region settings and you change it to China mainland. When you go back to your emoji keyboard, what you'll see is that the flag of Taiwan has disappeared. This is the compromise that Apple made to be able to sell iPhones in China, where there's about 1 billion people with money, and Apple likes to sell phones. The flag of Hong Kong, you can see, but you can't type it because of some... And there are these weird... As soon as your operating system says, these are countries and these aren't, you're going to piss somebody off. And if that's somebody you want to be able to sell things to, you get into a little bit of trouble. Now, Microsoft, I think quite admirably, went, we are not touching that. If you take a text file full of emoji on Mac OS and then you open it on Windows, you just get the country codes. They just come up as letters. There's only 3 flags that work on Microsoft Windows. They are the pride flag, the skull and crossbones, and the checkered flag that means you just won the Formula One motor racing. Now, I think this means Microsoft's official position on flags is that gay pirates are winning. Don't quote me on that, but it seems to send a pretty strong message, don't you think? And the third chapter of my personal journey down the delightful rabbit hole of plain text and all the different ways that it can go wrong was about 10 years ago, I visited Ukraine for the first time. And it was my first time visiting a country that used the Cyrillic alphabet. And the bit of me that likes fonts and typography just thought this was the coolest thing ever, because I couldn't read anything, but it all looked amazing. And I couldn't read the restaurant menus, and I couldn't read the signs on the shops and anything. But I could read all the license plates on the cars. And I said to one of the folks who was hosting us out there, we were doing a conference, I said to them, why do Ukrainian license plates use English letters? And they looked at me like, they don't? I'm like, yeah, they do. I could read them. And so we went down the rabbit hole of figuring out exactly what's going on. Now, weird coincidence, 1965, the same year that ASCII was ratified, there was a thing called the Vienna Convention on Road Traffic, which was a whole bunch of countries got together and went, look, if we're going to be driving all over Europe and crossing borders and stuff, it would be good if we could get some things straight about, like, do you need to have brakes that work? And do you need headlights? And also, it would be quite good if we could write down each other's license plates. And so they agreed that if you're going to drive your car around Europe, then you had to have a license plate which only used the Latin alphabet. Now, the Soviet Union, the USSR, was one of the signatories to the Vienna Convention on Road Traffic. Their license plates looked like this in the 1960s, and I am imagining that there was a meeting where somebody was like, comrade, why are we signing the Vienna Convention when our license plates, what if someone wants to drive their car out of the Soviet Union? And someone else went, comrade, you do not drive car out of Soviet Union. If you did, if you could get the necessary permits and government approval to be able to leave, they would give you temporary license plates at the border. There was a whole different registration system for Soviet vehicles being driven out of the USSR, and presumably you took those license plates back, otherwise bad things would happen to your family. Then in the 1990s, USSR kind of dissolved into all of its independent states, and most of them overhauled their vehicle registration system. And today, if you go to Ukraine or Belarus, well, I wouldn't go to Ukraine, Belarus, or Russia today, but if you visit those countries post-USSR, their vehicle registration plates look like this. And what they did in the slightly different subtle variations, but in Ukraine, they took the Cyrillic alphabet and the Latin alphabet, and they identified a set of glyphs. So these are not the same letters. They don't make the same sound, but they are the same shape. And they said, right, that's it. That is the set of characters that we are going to use on Ukrainian vehicle license plates. And if you take that set of letters and you shuffle them around a little bit, they spell Pike Matchbox. Now, I want you to remember that, because next time somebody says, I'm going to send you a plain text file, you say to them, do you know about Pike Matchbox? And if they say, oh, yeah, then they've seen this talk. Because as far as I'm aware, this is the only time anyone has ever used Pike Matchbox on the internet. They've seen the talk, and they know about big endian and little endian and code pages and encodings and combining characters and normalization forms and all the other things. Because when you say I'm going to send you a plain text file, what we normally mean is I'm going to send you a file that works on my computer. And I hope it works on your computer. But if it doesn't, well, don't come running to me, because I really have no idea what's going to happen, and plain text files can't really go wrong. Folks, thank you very much. I have a mailing list. This used to be the slide where I'm like, follow me on social media, but all social media is a massive pile of awful now. So yeah, if anyone wants to keep up with what I'm doing and meetups and YouTube, and I run little online training courses and workshops and stuff, join my mailing list. I won't sell your email because I don't know anyone who buys email and I wouldn't know how to do that. I send maybe one email a month. I type them by myself. You can reply to them if you want to have a chat. That's how old school I do my marketing. So yes, folks, any questions? I think you can clap in a minute. Let's questions first and then applause. Yes?
Yeah, when it comes to the Unicode comparison, when it comes to the normalization of it,
Yep.
are there libraries that you can recommend when it comes to on the say JavaScript clients and as well as the .NET runtime?
Mm-hmm.
Because or is it kind of like on the bare metal integrated with the platforms?
Yep. So JavaScript has normalization baked in.
Yeah.
Java does. Basically, if your programming language doesn't have Unicode normalization natively supported, you probably need to find a better programming language if you're going to build anything international. It's all built on what Unicode does is they define a rigorous set of algorithms, but they don't publish any code. So the Unicode standard says, look, if you compose this letter, it composes like this, and this letter decomposes into one of these, and then one of these, and then one of these, and that is all defined by the specification. So it is, when I say relatively straightforward, what I mean is that there's not a lot of guesswork involved in implementing it. And that's how most languages and platforms have a pretty robust Unicode implementation working on there. One of the things that I've just been playing with recently, which is really interesting, is normalizing names into URL slugs. So you can have, because I'm doing a bunch of work with some conference websites, and we got lots of speakers from Scandinavia and Poland and places that don't necessarily use the Latin alphabet. So how do you turn someone's name into something that will work well in a URL? And some of it, most Scandinavian stuff is like, we'll take the diareses off. We know that we normalize the like Magnus or into or whatever. Polish gets a lot more interesting because there's a bunch of letters in Polish that the Polish government, Polish Council on Orthography says, no, you don't turn this into English. And we're like, well, we kind of have to, otherwise it's not going to work when you click on it. And so there are some unofficial libraries that will take like the w in Łódź and just be, well, we're going to make it an L and don't look at it too closely. And then when you get into things like Cyrillic and Hebrew, and at that point you're like, well, you're just going to need to give us two different names, and we'll put one in the address bar and the other one on the web page. But no, in terms of things like normalization, they are baked into most languages now, all four normalization forms and string comparison that's smart enough to support it. So I can show you the slides in the pub if you like. I've got Java and JavaScript and .NET versions of it in the talk, depending on the audience. So.
All right, that'll require a drink or two. Go to it.
Yes, question at the back. Yeah. No. So one place where this pops up a lot more than you might think is when you share a PowerPoint presentation with somebody. If you're using a non-standard font, if you've installed your company's own font or anything, there is an option in PowerPoint to embed the font in the export version that you share with them. And there is an option that says, look, are you sending it to them to view or to edit? Because if you're sending it to them to view, it'll strip out all the font characters that aren't actually used, but then they can't make any changes. If you're sending it to them to be able to edit, it will embed the entire font in the PowerPoint file. So something which was 2 or 3 slides with text on them suddenly can become 10 or 15 megabytes if your company's official font is some massive thing with loads of Unicode and alternate representations and all that kind of stuff. So no, the fonts is a whole other thing. There is like actually I have another talk about typography, which kind of starts where this one ends and builds up on top of that, about how do we then get the letters up onto the screen. But no, getting the right representation at is only half the problem. Getting it to then look right and print right is the other half. And no, we haven't got a bulletproof way of doing that. There is a font, Google has a font called Noto. And I discovered yesterday that Noto is called Noto because it's short for no tofu. Because they explicitly said, we're going to build a font which has every single letter in every single alphabet in every single version of Unicode. So if you're using Noto, you will never, ever get that little white square with the board around it because we support all the characters, which I thought was quite cool. So, but no, the problem is not solved and probably never will be. So, but it's all right because big PDFs aren't a problem anymore because we all have gigabit fiber and Starlink, right? Yes?
How does this work with things like domains? I imagine it's created a whole load of registrars.
Question is, how does this work with things like domains? The answer is it's like a car crash happening in slow motion. So quite rightly, a lot of people are like, our company name is this. We are a Hebrew company operating in Israel. We want our company's name to be our website. DNS is built on ASCII because it was created in the United States and it was built on top of existing encoding systems. There is a system called Punycode, which is a way of turning Unicode into something that you can use in domain names and email addresses. The biggest headache, like the biggest stumbling block with this is security. Because, for example, you take, I don't know, Microsoft.com, but you replace the letter C with a lowercase Cyrillic letter S, suddenly you have something which looks visually identical to Microsoft.com, and you can get a certificate for it, but it's not Microsoft. And you would need to take the thing apart with a byte analyzer to be able to tell the difference. And so for that reason, any attempt to start supporting Unicode and things like domain names and email addresses has always met a combination of very spirited resistance from people who understand the InfoSec implications, very spirited apathy from people who are like, well, just use English, it's just fine, it'll work, and a minority of people in the middle going, no, this is actually quite important to us, and we haven't got a sort of cohesive path forward on that yet. There's still a lot of people working on it, but yeah, the only times in my life that I've ever seen Unicode used in domain names have been in phishing attacks and spam emails. And you do get a lot of those, and copy and paste them into a decoder and see what's actually there. It can be quite enlightening. Any other questions, folks, before we... Yes?
To your list, I had the guy who has the hammerandsecret.net.
So, sorry?
Hammerandsecret.net. Communist. Sign.
Yeah.
Net. He owns it.
Cool.
So you can
Yeah. Yeah. People have owned domain names that turn out not to be allowed. And there are lots of registrars that will take money off you for Unicode domains and then go, oh yeah, you can't actually have a website, but we've got your money, so good game. Yeah. Right, folks, let's wrap it up and go and grab a drink before I have to run and get a train. Thank you very much.